Welcome back, kids. So we'll continue with 5.2, energy and conservation of energy. There are 3 learning objectives under this subtopic. 5.2 is state the principle of conservation of energy, which we will be looking at in this video. 5.2b, apply the principle of conservation of energy. We'll be doing this in our example video after this. And 5.2c, state and apply the work energy theorem, W is equals to delta K. So we can define energy as the ability to do work. Alright, so energy here we associate as the ability to do the work. However, this simple definition is not precise, nor it is really valid for all types of energy. However, it works for mechanical energy, which we discuss in this subtopic. Alright, so in our syllabus and in this subtopic particularly, we are going to assume that energy is the ability to do work. And the energy here has a unit of joule. Okay, energy here, we use the symbol energy E. This is the total energy. And it has a symbol, unit of joule, and it is a scalar quantity. So energy does not have direction. It only have magnitude. Only magnitude. No direction. So the first mechanical energy that we're going to look at is the potential energy. It's the energy stored in a body or system because of its position, shape or state. So potential energy is the energy that we associate with position, shape or the state. There are 2 types of potential energy: gravitational potential energy and also elastic potential energy. So the definition of the gravitational potential energy is that energy that is stored in a body or system because of its position. So gravitational potential energy we associate with the position of the object ataupun any system lah dekat sini. So when you're talking about position, we usually associate dengan height. Okay, position we associate dengan height, di mana duduknya objek itu. Okay, so the equation for gravitational potential energy is U is equals to mgh, where U is the symbol that we use for gravitational potential energy. U adalah symbol untuk gravitational potential energy. M here is the mass of the body. G is the gravitational acceleration, which is 9.81 ms negative 2. And then H here is the height of the body from the initial position. Okay, so as we said earlier, gravitational potential kita associate dengan position, which is the height. So U is equals to mgh. Next, we have elastic potential energy. By definition, is the energy stored in elastic material. So kita kena ada material yang elastic as the result of their stretching or compressing. So any object that is going to stretch ataupun compress, dia akan store energy yang kita panggil elastic potential energy. So the equation for elastic potential energy adalah U is equals to 1 over 2k x square. Where U here we also associate dengan elastic potential energy. So basically potential energy, simbol dia adalah U. Dalam potential energy kita ada 2 jenis potential energy, iaitu gravitational potential energy ataupun elastic potential energy. So the elastic potential energy, U is equals to 1 over 2k x square, where k here is the spring constant. K here is the spring constant. Okay, dia adalah constant yang bergantung kepada the elastic material itu. And then x here is how much you're going to compress or extend the spring. X here is how much you're going to compress or extend the spring. Okay, next we're going to look at another type of mechanical energy, which is the kinetic energy. Okay, kinetic energy pula, energy of a body due to its motion. Untuk kinetic energy, kena ada objek bergerak, kena ada pergerakan, motion. We relate dengan velocity lah. Okay, kinetic energy wajib kena ada motion. So the equation for kinetic energy is K is equals to half mv square, where K here is the symbol that we associate to kinetic energy. M is the mass of the object and V is the velocity of the object as it is due to the motion. Alright, to recall back, we have talked about potential energy. Simbol potential energy adalah U, unit dia adalah joule. And then we have kinetic energy. Kinetic energy, simbol dia adalah K, unit dia adalah joule sebab masih energy. So potential energy here, kita ada dua jenis, gravitational potential energy ataupun elastic potential energy. Okay, gravitational potential energy is due to the position. Right, position, so dia kena ada height, mgh. Elastic potential energy adalah disebabkan oleh change in the state. Any elastic material that you are going to stretch ataupun you are going to compress. So U is equals to half kx square. And then kinetic energy pula adalah due to the motion. Okay, due to the motion, so K here is equals to half mv square. Alright, so next we are going to look at the principle of the conservation of energy. Principle of the conservation of energy. In an isolated system or closed system, the total energy of the system is constant. Alright, the total energy is constant. Okay, maksudnya nilai energi yang kamu ada dalam sesuatu sistem itu tidak boleh berubah. Whatever you had initially kena sama dengan after any changes that occur, you're going to have the same amount of energy. Because energy cannot be created nor destroyed. However, it can be transferred from one type of energy to another type of energy. Remember, ingat ini, energy cannot be created nor destroyed. Awak tak boleh wujudkan energi yang tak ada dan awak tak boleh hapuskan energi yang ada. However, kita boleh convert, kita boleh tukar satu-satu energi itu from a type to another type. Contoh, daripada heat energy ke sound energy, kita tukar. Alright? However, you can convert an energy to another type of energy. So, we're going to look back at the principle of conservation where dia cakap the total energy is constant, ataupun dalam kata lain, you can say that summation of the energy initial must equals to summation of the energy final. So, apa saja energy initially you had must equals to whatever energy that you're going to have by the end of the process. Total initial energy equals to total final energy. Sama macam kita belajar dalam chapter 3, conservation of linear momentum. Sama saja, ini adalah conservation of energy. In chapter 3, what we had was summation P initial sama dengan summation P final sebab momentum is constant. Total momentum kena constant. Begitu juga total energy is constant. So you're going to have the similar concept here. Alright, so dalam syllabus kita, we are only focusing on the mechanical energy. So we are going to talk about conservation of mechanical energy. In an isolated system, the total mechanical energy, E, kita guna simbol E untuk total energy of a system is constant. Samalah, in any case, energy kena constant. So the total mechanical energy is the sum of the potential energy and the kinetic energy. So basically, apa saja energy yang kita ada, the total energy adalah sebenarnya, the total energy since it's a mechanical energy adalah summation of kinetic energy dan juga potential energy. Okay, so when you say initial energy is equals to final energy, summation of E initial kena sama dengan summation of E final, your E adalah K plus U. Sebab ini initial, you have initial, maka subscript dekat sini pun akan jadi initial. Kan sama dengan K final plus U final. Alright, so dalam setiap case, we are going to use this principle of conservation of energy. What you have to do adalah kita kena identify what type of energy yang present initially dan what type of energy yang kita akan ada finally. Tak semestinya initially kena ada dua-dua kinetic dan juga potential energy. Boleh jadi initially you only had one type of energy. Okay, ini tak apa. Nanti kita akan tengok waktu kita jawab soalan. Yang penting you understand that total energy is constant. So K initial plus U initial kena sama dengan K final plus U final. Let us look at an example here. So let's say you have a person standing on top of a, tak tahu lah apa ni, tower lah kot, on top of a tower. So since this person is standing still here, dia tak ada velocity, so kinetic energy dia kosong. Dia tak ada kinetic energy. Alright. So sebab dia berada pada ketinggian yang we don't know what is the height, tapi h from the ground, so dia akan ada potential energy dekat sini. Sebab potential energy adalah mgh, gravitational potential energy. So secara totalnya initially, apa yang dia ada adalah total energy dekat sini adalah K plus U, potential energy. Kinetic energy tak ada dalam case initial, so kosong. Potential energy adalah 10,000. So the total energy yang initially adalah sebanyak 10,000. So whatever energy that you had initially kena sama dengan whatever you're going to have finally. Okay, so bila kita tengok finally, bila dia reach the ground, dia dah sampai ke ground dekat sini, dia lompat, dia sampai ground. What happen adalah dah no more H. H dekat sini dah jadi kosong. H here becomes 0. So bila H becomes 0, potential energy pun becomes 0. Tapi at the point dia hit the ground, dia akan ada velocity. Okay, sebab dia ada velocity, maka dia akan ada kinetic energy sebanyak 10,000 dekat sini. And the final energy here adalah K final plus U final. K final adalah 10,000, U final adalah 0. So this is the total energy dia ada. So as you can see, initial energy dia sama saja dengan final energy. Cuma jenis energy dia berubah daripada potential yang dia ada, finally dia jadi kinetic energy. Okay, so sepanjang proses dia melompat, what is going to happen is adalah you're going to reduce in the height. So let us say, katakan kita assume ketinggian asal ni adalah 10 meter, 10 meter. As you go down to this position here, what happen adalah your H is going to decrease. Mungkin dia jadi 8 meter pula. Okay, H kita tengah berkurang. Bila H berkurang, potential energy akan berkurang. Alright, the potential energy is going to decrease. Dan at that particular point, apa jadilah bila awak dah start lompat, you're going to have a velocity. Slowly your velocity increase. So bila velocity increase, kita akan ada kinetic energy lah pula. So daripada tak ada kinetic energy, mula ada kinetic energy sebab ada velocity. H berkurang, maka potential energy berkurang dekat sini. So as you can see, as you're decreasing in the height, the potential energy is reducing sampailah H sama dengan kosong, potential energy sama dengan kosong. Kinetic energy pula, as you're going down, your velocity is going to increase, leads to increase in the kinetic energy. Ini kita tunjuk involvement of different types of energy in a system. Alright.